Okay, we're going to start with our day 3 of section 4.3, which was mostly about our unit circle and finding exact values for trig functions. So do one quick refresher and hopefully this will seem like something you remember. So let's say that there is an angle like this, and we're going to say that this is 45 degrees. So this little angle here, 45 degrees, right? Hopefully you remember that while that angle is 45 degrees, if we do an angle like this, well, that is 45 degrees plus 360, right? And that's how we would find out what that angle is. So this is 45 degrees, but it's also 405 degrees, just depending on how many times we go around the circle. And so we're going to talk about that a little bit more today. And you're going to learn soon that our sine, cosine, and tangent are functions, just like all the other functions we've worked with. And a function is periodic if there exists a positive real number c such that f of t plus c equals f of t for all t in the domain of f. I'm sure that sounds like a foreign language, but it just says that if we're doing the sine of 45 plus 360, that equals the sine of 45, and that's because the sine function is periodic, and the smallest number c for which the function is periodic is called the period of f. Okay, so the period of sine is 360 degrees, or 2 pi. And all that means, if we go back to our picture, is that when we are going around this circle, right, we go 360 degrees. That was the period. That's how far we had to go to get back around to get the same sine value. So we're going to write down the rest of them. So the period of cosine is 360 degrees also, or 2 pi. And the period of tangent is different, of course. Can't all be the same. So this one is 180 or pi. And their reciprocals, cosecant, is the same, 360 or 2 pi. Secant, 360 or 2 pi. And our last one, our cotangent, is also 180 or pi. Okay, we'll do some quick practice and you'll see this isn't that complicated an idea. Just remember the period is how many times we're going around. So we want to find the exact value of the sine of 11 pi over 2, or 11 pi over 4. And if you think about just 11 over 4, right? So 11 pi over 4. Well, 11 over 4 is 2 and 3/4, right? So it's 2 and 3/4 pi. So that means when we go around a circle one time, we go 2 pi. But then we go another 3/4. And so we're going to draw a quick little picture of what this would look like. And this is the only one we're going to draw a picture on today. So 11 pi over 4. Well, 1 pi over 4 is like this. And if we were going to do 11 of them, remember how I told you about how these angles all match up on the unit circle, the bow tie angles? So if we start here and we do 1 pi over 4, 2 pi over 4s, 3 pi over 4s, 4 pi over 4s, now we've made it around to 1 pi because it was 4 pi over 4s. Then 5 pi, 6 pi, 7 pi, 8 pi gets us to 2 pi, right? But we're going to go 9 pi over 4, 10 pi over 4, 11 pi over 4. And we're going to end right there. And that is, on our unit circle, 3 pi over 4. So 11 pi over 4 matches up to 3 pi over 4. But we can't draw this picture for every problem, so we're going to have to figure out a way to do some algebra and answer these instead. So we take our function, sine, and we know that the period of the sine function is 2 pi. And we know this from up here. So we're going to take 11 pi over 4, and we're going to subtract as many revolutions as we need to get to one of our unit circle values that we know. So 11 pi over 4 minus 2 pi. Well, to do that, we need to think this is 2 pi over 1, and we want to get a common denominator. So this is really 11 pi over 4 minus 8 pi over 4. 11 minus 8 is 3 pi over 4. So that's where we get this 3 pi over 4. This is how to do it with algebra. This is how to do it with drawing a picture. But you'll see on some of these big ones, like this one over here, 585, we don't want to draw a picture for that. We'd have to make a bunch of loops. So our sine of 11 pi over 4 equals the sine of 3 pi over 4. We can look on our unit circle and see that that is the square root of 2 over 2. So the sine of 11 pi over 4 equals the square root of 2 over 2. All right, now we'll try this one. Cosecant of 7 pi over 3. Well, cosecant, our period is 2 pi. So we're going to start with 7 pi over 3 minus 2 pi. Need to get a common denominator, so this is 2 pi over 1. So we need a 3 on the bottom. So we're going to have 7 pi over 3 minus 6 pi over 3, and that equals 1 pi over 3. So the cosecant of 7 pi over 3 is equal to the secant of pi over 3, which from our unit circle is 2 over the square root of 3, but we know it can't be written like that, so we have to times square root of 3 over square root of 3, and we get 2 square root of 3 over 3. So that is our cosecant of 7 pi over 3. All right, now we're on to one with the degrees. So tangent, the period of tangent is 180. So we're going to have to start taking off 180s. So we'll do 495. Now, since we're a negative angle, that means we're spinning this way, right? So we're going to take off backwards. So instead of subtracting 180, we're going to add 180. We get negative 315, right? Add 180 again. We get negative 135. We're going to add 180 again, and we get 45. So the tangent of negative 495 equals the tangent of 45, which from our unit circle is 1, because it's the sine over the cosine or the y over the x, and since you have the same values at 45 degrees, that makes the tangent be 1. All right, last one, cotangent of 585. Our period is 180, so we're going to do 585 minus 180, we get 405, minus another 180, we get 225. So now we know our cotangent of 585 is equal to the cotangent of 225, which is a value from our unit circle. So cotangent, though, is the reciprocal of tangent, right? So tangent of 225 from our unit circle is 1. Well, cotangent is to flip that over, which is also 1. And that's it. That's how we use the period aspect of a function to find out its exact value. So you can make all these loops, or you can do the algebra and get it down to one of these values that you do know your period or your trig function for, your trig value for from your unit circle. So these are what you're trying to get down to, is values that are from your unit circle. All right, last one. These are going to be real quick. Use your calculator to find the following and round to 4 decimal places. So if we're trying to find the secant of 2.7, we know that secant is equal to 1 over cosine. And that's how we do it. But the tendency in the calculator is going to be to do this. Okay, that's not the same thing. In the calculator, you need to do 1 slash cosine 2.7 and hit enter. Then you'll get negative 1.1061. Okay, so to do cotangent. Cotangent of 7.3 is 1 over tangent 7.3. So in your calculator, temptation is to do this. That's not how you do it. We do 1 over tangent 7.3, and we get 0.6186. Okay, reciprocals are things that we need to kind of commit to our memory. It'll save you a lot of work. Now, remember on the unit circle, I told you there were about 3 values you needed to know. There's actually 5, but I lied to you, so it's okay. So the first one is 1/2. The sine or the cosine is always 1/2 square root of 3 over 2, square root of 2 over 2, 0, or the square root of 3 over 3. Now, these are sine cosine values. These two are tangent and cotangent values. So the reciprocals are what happens when you flip them over. Well, if you memorize them, you don't have to keep doing the work every single problem to flip them over. So 1/2, when you flip it over, it's 2. Square root of 3 over 2, when you flip that over, it becomes 2 square root 3 over 3, because you can't have the radical on the bottom, so that's what it turns into. Square root of 2 over 2 becomes the square root of 2. 0, when you flip it over, is undefined. And the last one, square root of 3 over 3, when you flip it over, it just becomes the square root of 3. So if you can commit these reciprocals to memory and you can memorize the unit circle, you'll be able to do all these problems that we're learning how to do without writing anything down, without using your calculator, without doing any work at all. So get busy memorizing.